So in this question, we're going to use vectors to find the area of a triangle. Now this triangle has got three vertices, A, B and C. Now we've drawn them on this three-dimensional plane here. Now you'll notice I've got a point P. Now point P is perpendicular to AB. That's an important fact that we need to try and prove as well in this question. Now the line P, or the point P on the line AB, is in the ratio of AP to PB is 3:1. So basically what we're saying is this line here is 3 times longer than this line here. So they're the properties we need to do. So what I'm proposing is to find the length of this AB and the length of PC, and then use the elementary formula for the area of a triangle, which is base times height over 2. So with that in vector format, I've got my vector AB. So if I find the magnitude of that, so I've got AB times that by the magnitude of the height, which is PC, and then divide that by 2. So that's what I need to try and do. So these are my building blocks. So I need to find AB first. So let's go for that. So the magnitude of AB. So first of all, we need to find B minus A to find the distance. So B minus A. So that becomes 5 minus 1. That's 4. Then we do 9 minus 1, which is 8. And then minus 5 minus 3 is minus 8. And then what we do is, to find the magnitude, we take the square root of the sum of the squares of inside these vectors. So the square root and then the sum of these squares. So we've got 4 squared, 8 squared and minus 8 squared. So let's just quickly work out what that is. So that'd be 64, that would be 64, that would be 16. Add them together, we get 144. So square root of 144, which nice and conveniently gives us a magnitude of 12. So AB is 12. So let's carry on down here, see what we've got. So now that's our first part. I'm going to divide that by 2. Now we need to find PC. So first of all, we need to find the point P. So where is point P? Well, it's on the line AB. So we've got our line B to A, but it's 3 times closer to B than it is A. So what we have to do is kind of use our midpoint formula. So the midpoint formula for this is not the same as the middle. It's 3/4 of the way along and 1/4 the way along. So what we do is we have to multiply each one of these by 3, add it to each one of these times by 1, and then divide by 4. So this is what it will look like. So we'd have point on B, which is 5, and then we times that by 3 because it's 3 times closer to B. And then we'd add it to each of the components as we're going along the line. So here we've got 1, so now we want 1 times 1, and then we divide that by 4. So that gives us our 3/4 of the way along the vector AB for there, for the I component. Now for the J component, we need to do the same with these. Now for the J component, we've got 9. So we do 9 times 3 plus 1 times 1. So that takes care of that one, and again divide that by 4. And now for the last one, we've got the minus 5. So we need to times that by 3. So minus 5 times 3 plus 1 times this one, which is 3. And then divide all of that by 4. So it looks pretty complicated, but all we've got to do is, as that's 3 times closer, we treble all of those and add it to 1 times all of those, and then divide by 4, because that's the sum of the shared ratios. So now point P, that gives me 5 3s are 15 plus 1 over 4. That's nice and handy, that comes out to 4. Then this one here, we've got 3 9s are 27 plus 1 is 28 over 4, that gives me 7. So 28 over 4, that gives me 7. Minus 5 times minus 3 is minus 15. Plus 1 times 3, so that gives me minus 12 over 4. Minus 12 over 4 minus 3. Okay, so we got the point P. So now what we need to do is work out what PC is. So PC. So what is that? Well, PC is just C minus P. C minus P. So we've got 6 minus 4, that gives me 2. Then we've got 5 minus 7, that gives me minus 2. And then minus 4 minus 3, that gives me minus 1. So that's my line PC. Now what I can do is I can use the dot product quality to find out if PC is actually perpendicular to AB. So if I just put a line there just to do my test, I should get PC times AB, and if that's correct and it's orthogonal, it should be 0. So PC, so I've got on the point there, I've got 2. And on AB, I've got the point 4. So 2 times 4. And then add them up with minus 2 times 8. So now I've got minus 2 times 8. So it's kind of tricky here. You've got to keep looking for the different vectors and remember which one you're actually looking at to be correct. So now we've got minus 1 times minus 8. So now I've got minus 1 minus 8. Okay, let's just simplify this. 2 4s are 8 plus minus 16, and minus 1 times minus 8 is plus 8. So that checks out, that is 0. So I'm now happy that PC is perpendicular to AB. So now what I can do is I can work out the magnitude of PC. So let's do that. So magnitude of PC. So that equals the square root of all these squared. So now I've got 2 squared plus minus 2 squared plus minus 1 squared. Well, that's 4, 4, and 1. So that becomes square root of 9, which just gives me 3. So that gives me 3. So 3 12s are 36, divided by 2 is 18. So therefore my area of A, B, C equals 18. And as we're talking in vectors, we're talking 18 units. So area of ABC is 18. So the next video, I'm going to show you how to do this using the cross product, and we use matrices and determinants. Okay.